day. My name is Nurulin Etiamot, a third-year college student taking Bachelor of Technical Vocational Teacher Education, major in Heating, Ventilating, and Air Conditioning in Zamboanga Peninsula Polytechnic State University.
Ever wondered how your car's air conditioner knows exactly when to turn on and off? Even thought the engine keeps spinning the whole time? The secret lies in the clutch and pulley system. Here's the cool part. The pulley on your AC compressor spins all the time with the engine belt, but the compressor only runs when you need cold air. So how does that happen? When you press the AC button, an electric current energizes an electromagnetic coil. This creates a magnetic field that snaps the clutch plate onto the spinning pulley, connecting the compressor to the engine. And then boom! The refrigerant starts flowing and cool air fills your cabin. Turn the AC off. That magnetic field disappears. The clutch releases. The pulley spins freely again, and the compressor rests until next time. Fun fact: a worn-out clutch or pulley can cause a squealing noise or no cooling, which are common symptoms of clutch failure. So next time your AC starts acting up, it might not be refrigerant. It could be this clever little coping system. Here's a second fun fact. That metallic click you sometimes hear when the AC turns on, that's actually the clutch engaging. Here's the last fun fact. If your clutch stayed engaged all the time, your compressor would wear out in just a few months. That's why the system gives it rest periods between cooling cycles. In this video, I will be discussing how auto AC magnetic clutches and pulleys work. Have you ever wondered how your car air conditioning turns on and off with just a press of a button while the engine keeps running? The answer lies in a small but powerful component, the magnetic clutch and pulley system in your vehicle's AC compressor. In this video, we'll break down how it works, what it does, and why it's crucial for keeping you cool on the road. To understand the role of magnetic clutch and pulley, let's first look at the picture how automotive AC system works. Your car AC system has four main components: the compressor, condenser, expansion valve or orifice tube, and evaporator. The compressor is the heart of the system, pressurizing refrigerant and moving it through the AC cycle. But here's the key. The compressor doesn't run all the time. That's where the magnetic clutch and pulley come in. What is magnetic clutch? The magnetic clutch, also called the AC clutch, is mounted on the front of the compressor. It's responsible for engaging and disengaging the compressor from the engine's power. Here's how it works. A pulley is connected to the engine via the serpentine belt. This pulley spins continuously whenever the engine is running. The compressor, however, only needs to operate when you switch on the AC. That's where the magnetic clutch comes in. When you turn on the AC, an electric signal is sent to the clutch coil. The coil generates a magnetic field that pulls the clutch plate toward the pulley.
The clutch engage, connecting compressor to the engine, and the compressor starts to turn. When the AC is turned off, power to the coil is cut. The magnetic field disappears and the clutch disengages, allowing the pulley to spin freely without driving the compressor. The clutch AC assembly typically has three main components. The first one is the pulley. Connected to the engine via a belt, it spins constantly when the engine is running. The second one is the magnetic coil. Creates a magnetic field when energized, pulling the clutch plate in. The third one is the clutch plate or hub. Connects to the compressor shaft and engage or disengage based on the coil's magnetism. When the system is working properly, these three main components operate smoothly to engage and disengage the compressor on demand. The magnetic clutch plays a vital role in AC systems, efficiency, and longevity. Without it, the compressor would run continuously whenever the engine is on, wasting power and wearing out the system prematurely. By engaging only when needed, the clutch, it saves fuel by reducing engine load, it extends the compressor's lifespan, and it helps maintain the correct temperature inside the cabin and also prevents overcooling and system strain. Like all mechanical parts, the AC magnetic clutch can develop issues over time. Common problems include worn clutch plate, causes slipping or poor engagement, damaged coil, prevents magnetic field generation, faulty bearing in pulley, produce grinding or squealing of noises, and electrical issues, broken wires or bad connections to stop the clutch from engaging. To maintain your AC clutch, keep the belt tension correct, ensure electrical connections are clean, and inspect for noise or vibration. Early maintenance can prevent costly compressor replacement. You can perform a simple test to check if the clutch is working. The first one, start the engine and turn off the AC. The clutch plate should be still. And the second one, turn on the AC. The clutch plate should snap and spin with the pulley. And the third one, if doesn't engage, check the electrical circuit, fuse, or clutch coil.
How clutch works in a car. Clutch is used to transmit power from the engine to the gearbox. It is bolted on the flywheel of the engine. Clutch consists of a friction plate, also called the clutch plate, a pressure plate jointed with a diaphragm spring. Pressure plate is mounted on the transmission shaft and can move back and forth. It is also connected with the friction plate and applies constant pressure on the friction plate. And due to this, the friction and pressure plate are always in contact and transfers power to the gearbox. But when we press the clutch pedal, the clutch fork pushes the diaphragm spring, releasing the pressure plate from the clutch plate, resulting in no power transfer to the gearbox.
So now you know how the magnetic clutch and pulley system keeps your car's AC efficient and responsive. A simple magnetic connection makes all the difference, turning the compressor only when needed and saving both energy and wear.